Example 7 on unsteady flow. Show that for a given vertical cylindrical tank, the time required to lower the liquid level a given amount is equal to the total volume of liquid discharged divided by the average of the initial and final rates of discharge. Then apply it to a cylindrical tank 2 meters in diameter and 3 meters high containing a 100 mm diameter orifice on the bottom portion with coefficient of discharge 0.62. So determine the time required to lower the liquid surface from 3 meters to 2 meters. So take note that in this problem here, uh, we can only apply this when the area S is constant. We cannot apply this for varying areas. So Q initial is kaotog, so C area O square root of 2G HI. Q final is C area O square root of 2G HF. So the average discharge is half of this sum. So Q average is 1/2 of quantity C area O square root of 2G HI plus C area O square root of 2G HF. Since C area O square root of 2G is common to these two terms, so let's factor it out. So Q average is C area O square root of 2G over 2 quantity square root of HI plus square root of HF. Then Q average times time equals volume, or time equals volume discharge over Q average. So volume is just this part here, area S times the height. The height is HI minus HF. So substitute area S HI minus HF over C area O square root 2G over 2 times the quantity square root of HI plus square root of HF. Then this is 2 area S. Then let's factor HI minus HF into square root of HI minus square root of HF times the quantity square root of HI plus square root of HF. So 2 area S quantity square root of HI minus square root of HF times the quantity square root of HI plus square root of HF, then divided by C area O square root of 2G times quantity square root of HI plus square root of HF. Then we can cancel this square root of HI plus square root of HF, and the result will be the direct formula for the time to lower the surface from HI to HF. So remember, this is the direct formula for computing the time to lower the liquid surface from HI to HF. Then let's apply it to this problem here. Q initial is C 0.62, area of orifice pi 0.05 square times square root of 19.62 2G times HI, which is 3. So QI is 0.03736 cubic meter per second. Q final is 0.62, quantity pi 0.05 square root of 19.62 times 2. So Q final is 0.0305 cubic meter per second. Therefore, the average is 0.03736 plus 0.0305 divided by 2. So the average discharge is the average flow rate is 0.03393 cubic meter per second. Then Q average 0.03393 times time equals pi radius of cylinder 1 square times quantity 3 minus 2. So in other words, this is 1 meter. So solving for the time, 92.59 seconds. Or using the direct formula, time equals 2 area S pi 1 square times quantity square root of 3 minus square root of 2 over 0.62 pi 0.05 square root of 19.62. Cancelling out pi and using the calculator, it will give us the same answer. So that's it for this problem. You may use this only for tanks with constant areas.